Everybody to our session. My name is Ciprian Jichici. I'm the general manager of Genisoft. Together with me is my colleague Roxana Goidaci. She's the chief architect of Genisoft. Today I'm offloading the pressure of demos to my colleague, so she's the one who has to pray to the gods of demos for everything to work. We've got some pretty interesting stuff today. So happy to see a packed room. First of all, as I was instructed, a big thank you to all the sponsors for this conference. I just have to personally thank to the organizers for having me here. Each year passes, this conference is getting bigger and better organized, so a big congratulations to the folks who are organizing this. It's getting to be, I think, the most important independent conference in Romania, so I think they deserve a round of applause for that. It's great. I'm also very happy to announce that it's the first year the companies I am involved in, Genisoft and HTSS, are platinum sponsors for the conference, so we're investing more and more into these types of events. With that, let me get into the stuff that we have prepared today for you. It's going to be a pretty interesting talk. As you've probably seen in the description of the session, we're going to cover a topic that is pretty interesting. Is there anybody from Microsoft in the room? No? Great. So then I can speak freely. Just kidding. As you probably know, I'm part of a special program called the Microsoft Regional Directors. It's a program that gathers about 100 of the at least of what Microsoft thinks of being the best professionals out there in the world. I'm very proud to represent Romania in this program. The thing with this program is we do a lot of stuff pro bono for Microsoft. What we get instead is early access to technology. So we have very good connections to the product teams, to the folks who are designing, engineering, and implementing the stuff that you use all the day in your daily work. Now, if we would give a different title to today's presentation, a shorter one, I would say the death of IIS. Okay? When I say IIS is Internet Information Services, it's not really a death. It's more like a transformation. I'm going to talk a lot about the huge transformations that are undergoing in this particular area. Well, the title is How Sharp is Your Katana? It's not really about martial arts, although I would love to be about martial arts. It's really about how sharp are your skills and how well prepared are you for the new world that is coming upon us. And that is a world where the name of the game is going to be cloud, and the other name of the game will be IoT. I like acronyms, don't you? Sometimes I do some exercises and I start writing down all the acronyms that I know. Usually after about a half an hour I stop because I'm bored. Sometimes I get to the letter D or E. Sometimes I get further, right? When I say about IoT, I mean the Internet of Things. Or other people name it things of the Internet. Doesn't matter. It's a huge transformation. 10 years ago, 15 years ago, having an IP address was such a big thing, right? Dude, you're connected to the Internet. Wow, right? Today, we have many IP addresses. I carry a phone, a tablet, a laptop, and whatever weird gizmo, I don't even be aware of it, right? My car and other things that have Internet address. So the world of connections and the world of communication is changing radically. In one of my trips to the United States last year, I've seen a fabulous project. It was about sprinklers, right? And I see some faces like, what the heck is this guy talking here? He's a fabulous project about sprinklers, right? Well, it was fabulous because what they're doing, this is a project with the National Weather Agency in the United States. They're trying to significantly improve the prediction of temperature over reduced areas of land. In other words, they are not really interested of predicting temperatures for tens of thousands of square kilometers, but they are looking to improve predictions for maybe hundreds of square meters, or at most square kilometers or miles as they use. The way they want to do that is they want to implement a web server into the largest number of sprinklers that they can. Make those web servers call to a cloud service that collects the data continuously, feeds it into a big data analytics model, and then performs predictions. The idea being that instead of having one weather station every 50 kilometers or so, you have tens of thousands of mini weather stations that do one thing. Actually, they do two things. They spray water and they measure temperature. And while this is a pilot project, it is a very, very interesting sign of things to come. Lots of little gizmos, lots of little devices. What do they have in common? They all have a web server in them. Like, what the heck? Right? A few months ago, somebody from the company came with the idea to use those little devices. They are the credit card, the Netgear push-to-TV stuff. That enables you to communicate HDMI wirelessly with your TV. You plug it into TV's HDMI, and then you can just project with your laptop, tablet, or whatever. That thing has a web server in it. So that's the world we're going towards. Now, today's talk is split into 4 big sections. The first one is I'm going to get into some details about this new world of web stacks that we are living in and that is coming upon us. The second is I'm going to introduce a real-world business scenario. There's a small chunk of an applications that we have developed for one of our customers that takes advantage of some of these new things that are developing in the .NET web stack. The third, we're going to talk about a specific implementation from Microsoft, which, and it's no coincidence, is called Katana. And finally, of course, we're going to talk about security, because today security is the name of the game. So without further ado, let me get into the detail. Now, as I've already said, the Internet of Things is here. That's just a very small example. That's our living room. You can't imagine what goes on in our living room. 2 days ago, I was watching one of my favorite HBO series, Game of Thrones. Well, I know, I'm a geek, right? So if you're a geek, you have to like Game of Thrones. I was watching that, and at some point, there's a pop-up on my TV. It said, "I found new media." Like, what the heck is that? Well, I was connected to a wireless connection that was connected to another wireless connection that eventually popped into a switch, and somebody introduced a network-attached storage there with some media files on it. And like, dude, I found new media. It's like, whoa, okay. Earlier this year, I bought a car. I'm a huge fan of cars. It's a very nice car, has lots of features. I forgot to tell me about one of them. So at some time when I was driving, it's like just a very nice voice. It wasn't Cortana, I have to admit, but it was a nice voice. It said, "You have a new message. Do you want me to read it to you?" It's like, okay. So the Internet of Things is coming upon us, and there are more and more things that will be connected that have to communicate. So naturally, in the community, there are new things that are developed that aim to respond to this trend. One of them is OWIN. The acronym, as you can see, stands for Open Web Interface for .NET, or simply put, the death of IIS. One of the big things that we have to deal with today is the fact that you need to have a web server in order to implement web services. It's like, duh, of course, right? How would I run a web service if I don't have a web server? The problem with today's web servers, though, is that they are big, they are chunky, and they have lots of features you never, ever use in your application. That's a big problem, right? They are fantastic. Don't get me wrong, I'm a huge fan of IIS. I firmly say that it's the best web server out there. It's the point of this. It's the point that on our average application that we deploy to the average enterprise company, which needs to serve the average number of up to 100,000 users, then we do not use, let's say, 80% of IIS's functionalities, because we don't need them. So the idea is here, what if I could build dynamically my own web server from my application and still get all the goodies that I need? Authentication, authorization, caching, data access, so forth, so forth, so forth. I want them on my terms. And that's what OWIN is about. Is basically decoupling the application from the server. It's a big step forward, and probably the number one thing that I like about it is that it's community driven. So that's not Microsoft, that's not other company, it is community driven. And that's a good thing. Now, if I were to give you a different definition of OWIN, a more geeky one, would be this one. It's a Funkified dictionary of string and object and task. And believe it or not, this is OWIN, right? If you strip it down to the bare bones, OWIN is just a function template. And of course, we're going to talk about this, and we're going to explain all of this. But basically, this is it. It's an interface that enables you dynamically to chain middleware components in your own custom web server, built and configured when you initiate your application. And it is a big step ahead. So let's get into the details of OWIN. Now, the main role of OWIN, as I mentioned, is to provide decoupling between apps and servers. And of course, apps are nothing without their respective frameworks. So this is the first time, really, when we as developers on the .NET platform are able to eliminate dependencies between two things. If you start thinking about your own applications and the types of dependencies that you introduce every single day in your applications, you'll see that, or at least I hope that you will agree with me that this is really a big, big step forward. So let's sharpen up things, right? The question in the title of our session is, how sharp is your katana, right? Of course, I'm not talking about the masterpiece on my slide. Actually, for those of you who know a little bit about Japanese traditions and history, you know this is actually a form of art. Not only handling the thing, but building the thing. I would argue building the thing is even more spectacular than handling the thing. We're living in a real world, so I'm not going to talk about the katana, the traditional Japanese sword, but I'm going to talk about Microsoft's project codenamed Katana, which is nothing more than Microsoft's implementation for OWIN. So as we speak today, we do have support in ASP.NET and in the .NET stack, actually, to be more accurate, for OWIN functionality. The code name is Katana, and there are tons of functions that we can already use. They now come in the form of NuGet packages that you can refer into your project, and that you can do lots and lots of things about that. Let me get to the more applied sciences into the talk. So I'm going to introduce a real-world business scenario. As I mentioned, it is one of our customers. We have developed for them a mobile application. It is a chain of pharmacies across Romania. They have several hundreds of locations, and they want to have mobile presence. So we've built for them an application, and in our data center at HDSS, there's an endpoint, https.mobile.htss.ro/sensiblue, which is the endpoint that serves these applications. And of course, the critical thing about this is I really want to know if there's an issue with that endpoint before customers using the mobile app start complaining about it. Think about how you handle a mobile app. Usually when I download the mobile app, it doesn't work in the first 30 seconds. I say, it's crap. I don't want it, right? So it's critical to make sure at least the endpoint is accessible and working. So the problem at hand for us here was we want to do some testing for the REST endpoint. And of course, for obvious reasons, there's absolutely no use of doing the test within the data center, because that's not realistic. I want to see if the endpoint works from the outside. So the immediate idea was, what is the closest point outside? Well, not in kilometers. The closest point outside is the cloud. So what we decided was, what if we do an automated REST endpoint tester that lives in the cloud and does periodic tests for these endpoints, logs some results into a database, performs some alerts, and maybe does some automatic restarting of the services in the data center if there's something wrong with the endpoints. And that was our initial target. So we came up with a high-level architecture here. And we thought about the following. Well, it's about periodic testing, right? So if it's about periodic testing, then we probably want to do a worker role in Windows Azure, because it has to run continuously, and it has to do a lot of stuff, and so forth and so forth. So we probably want to make it generic because we're planning to develop a lot of mobile apps. So there's a configuration XML there that is stored in the Azure blob storage, where we can define those tests without having to recompile or to re-engineer the actual worker role. And there's a SQL Azure database, of course, where we store the results of the tests. So far, so good. But what happens when you change the configuration of the tests? That was the first question. And the immediate question, of course, was, well, of course, you have to reload the content in the worker role. Well, how do you let the worker role know that it has to reload the content? One way to do it, which is not that elegant, in my opinion, is you have to continuously poll the blob storage to see whether something was changed or not. That does not work very well. And especially if you have a large number of tests, it won't work at all. So the idea was, what if when we upload the new XML file, we call into the worker role and say, hey, dude, there's a configuration change. Reload your stuff. That's fine. Now the question here is, who gets to do that? The answer is, of course, only somebody who has the rights to do that. Otherwise, after this session, half of you would try to reload the configuration in our worker role. So the idea was, well, we want to do this with authentication, of course, right? Well, what's the immediate solution for authentication? Of course, Windows Azure Active Directory. So we have a small management application that uses a Windows Azure Active Directory account to authenticate into the worker role and let the worker role know that the configuration has changed. Pretty simple, right? Now, as you know, in a worker role, you might use or might not use IIS. I'm not happy about using IIS in a worker role for several reasons, but the main reason is, for this, I actually only need two things. I want it to authenticate against Windows Azure Active Directory, and I want it to call a controller. So, of course, what we did was we implemented Web API into our worker role. We implemented authentication. Yes, we did it without touching or referring IIS. And the way we did it, with using OWIN and Microsoft Katana implementation on top of it. So let's just get into the first demo of the day. And if we manage to make this work, we'll get a look at, I think you have to do this. We'll get to have a look at some of the implementation. Roxana will show us some stuff. I will get with some extra explanation into this.
First of all, I will open the Windows Azure Management Portal to take a look at the configuration of the services deployed here.
To let everybody know, this is a reduced example, but it's live. It runs on the cloud. It inputs now test data, so it's something that really is working now, right now. Okay.
To see that, I will enter on the Cloud Services section, where you can see the service, HTSS Mobile, and it is running. Let's click on it. You can see the instances. I only have one instance running here. And also, let's look at the certificates section.
I will get back to this later. Why do we need certificates? And actually, why do we need HTTPS as exposed from our worker role? And there's a good reason for that. But we'll talk about that later.
As Ciprian mentioned before, we are using two types of storages in our service. And to configure this, let's take a look at the configuration settings. We have two settings here, the storage connection string, which is the connection string to the Azure blob storage, and the configuration container name to be able to call it from my code. So we are using a SQL database, the mobile services monitoring database, where the test results will be stored. About the storage, the blob storage, you can see here I have in the storage section the HTSS mobile container. Let's take a look at the containers. The REST endpoint test container, which contains the XML configuration file where all the list of tests are stored for every application I will monitor in my service.
Just a quick note here, what we tried to do, we tried to make a generic REST endpoint tester, and we tried to push into an XML file everything that needs to be in place in order to configure automatic testing for any type of REST point, either with GET or with POST or with different verbs, with different parameters and so forth. But that's the technicality.
Also, Ciprian mentioned about security. We have here in the Active Directory page one organization configured, and there on the application section you can see that we configured the worker role application and also the management client application that will force the configuration files to be reloaded. Next, I will show you a little bit of code here. But first, let's connect with Visual Studio to all these storages we talked about. First, the SQL Azure database.
Don't you love those server names in SQL Azure? It's like mobile services.monitoring, right? That's just cool.
I have some connection problems here.
Yeah, I think you have to check if you were connected to the VPN. No. Just on the connection. Yeah, the VPN has died. There's limitations there. You can't access from any IP address those services. You know, security. So we have to go through our VPN. It's going to probably take a little bit of time until it updates.
So the mobile services monitoring database, it's a simple relation object model with 3 tables. The application table, where I define all the applications I will monitor in my cloud service. The test list, and this is the most important table, the test results table.
Just in case you're wondering who the heck is designing a database with 3 tables, as I've mentioned, we stripped down everything for the purposes of this demo. Okay, so that's why you see there are 3 tables.
To see some data in the tables, I will run the only one procedure here.
Yeah. That's a database with 3 tables and 1 stored procedure, right? Wacky.
get statistics for, let's say, the past 10 hours for our service.
Well, yeah. Our internet connection is not the greatest one that is there. Oh, cool.
Okay, so I have one application here in my demo, and let's say 10 hours. And
What we're expecting now is we want to get back a statistic with the failed and successful endpoint tests that were run in the past 10 hours.
Okay.
As you can see, we do have some failures, but the rate of failures is probably not relevant. So we're happy with that. Usually, if the rate of failures is under 2.5%, we're happy with that. It's not a problem. Because there are many transient situations where, as you can see, there are lots of moving parts in this little thing that we're showing you. So under 2.5% is good. We're happy with that.
So you can see here the list of tests I talked to you about. Also, these tests are stored in the blob storage. So again, with Visual Studio, we can see the container, HTS mobile, REST endpoint test container, where the XML configuration file is stored.
Can you show just from the,
Yes.
yeah, just a simple flavor of what that looks like? You can
It's
define.
a simple XML configuration file with a list of tests. A test is described with a name, description, URL of the REST service we are calling, the type of method, and also a validator method.
And also, in
for
case
the
you're
result.
wondering what that empty GUID is doing there, it's a special way of letting know our backend service that this is a test call, right? So there are things that need to be done in the backend service, and you want to need if you're called from a test environment. For instance, we're doing automatic provisioning of loyalty cards, right? We don't want every time that we call the backend, we don't want to create a new loyalty card, right? Because then our customer at the end of the year would have said, we have 30 million customers in Romania, right? It's like, well, yeah, you know.
So let's take a look at the client application that forces this configuration to be reloaded. I only start it for now.
So happening here, we're now calling into the worker role to let the worker role know, dude, you have to reload the configuration. And by the way, there's an optimization here. The configuration is reloaded on the fly. So the worker role never stops, never recycles, actually never ends doing the test. It's an in-memory load, automated load, which is kind of what we were actually expecting from it. And of course, you need a user fat, so you can prep all your cameras.
You have a copy-paste bug here.
Yeah. It's going to be recorded, so you can just do a stop of the session and you can use the password later, right? So
No, it doesn't
oh,
let me enter it.
yeah.
So, okay, I will have to enter it manually.
That's probably, Visual Notepad always has its quirks. That's why I always like to use Visual Studio. Whoa,
Yes,
success.
thanks.
Well, can we get a password? So one thing you will notice here in the meantime, an authentication window popped up when we called, but we never did that, right? I will explain later why that popped. What happens behind the scenes, we're actually getting an authentication token from Active Directory service in Windows Azure. So the next time we want to call the endpoint, and we might try to do that, there's no authentication needed. Why? Because we already do have the authentication token. And unless that token expires, we're good to go. So we can use that token as many times as we want. So now you can understand why we need HTTPS in terms of transport level security, because you have to protect that token. If you are now stealing our token, you can call our endpoint in our worker role. Okay, so I think it's time to move back to the slides. Thank you. Let's get to the next part of our discussion. So let's get into the details of the stuff that we call Katana. Let's see how we sharpen our Katana. Now, when Microsoft started the project, there were 3 main objectives into this one. The first one was make it portable. Or in other words, let us developer substitute components of the web stack as we wish. Namely, not force us into a predefined stack of middleware components like a web server does today. Take any web server, take Apache, take IIS, take whatever you want. They force you into a fixed stream of middleware components that process your requests. There is no way to change that. You can only disable some of them, but the server still takes resources, still consumes memory, and still needs lots and lots of configuration. So portability was the first one. The second one was modularity and flexibility. Basically what we're looking here is let the developer decide how the web server should look in that service. And that's pretty neat if you ask me, right? I want to decide on my own, on my terms. Well, it's true, that comes also with a lot of responsibility. Because if you do the things in a wrong way, then you're going to pay the price. If you put, for instance, web API processing before authentication, guess what? You'll never be authenticated. You think you are, but you're not. So it also comes with a lot of responsibility. That's important to know. Finally, we want to do the stuff lightweight. Because if I want to run a web server on a banking card, and I'm not crazy, we're going to get to that day. If I want to have a web server in my banking card that will be able to talk to backend cloud services, then I really want to be lightweight. And believe me, as I've said, we're going to get there. Now, let me go a little further with this one and do a bit of intermezzo. This is one of my favorite topics, is about software scalability, right? And common wisdom says that the scalability of a piece of software is a direct dependency on its complexity. Now, is there anybody in the room who knows Scott Hanselman? You probably do, right? So Scott has a very interesting corollary to this one, and I just love it. His corollary says, a piece of software that does absolutely nothing scales infinitely, right? And mathematically, he's right. It's true. The less you do in your piece of software, the more you will scale. And sometimes, especially for old school architects, the approach is like, dude, you're crazy, right? It's like, how am I going to do less? Because I have to do this and this and this and this. Well, you can do this and this and this, but you can do it in a modular way. And you can do it in a pluggable way, and you can do it in a controlled way. So I think it's a very important concept. Now, Microsoft's implementation of OWIN is the Katana project. There's one core thing to the Katana implementation, and that's one interface. It's called iApp Builder. Around iApp Builder involves everything in terms of implementing the OWIN concept. And what iApp Builder actually does, it enables you to chain middleware components. And mind this, those middleware components can do absolutely anything. They can be out-of-the-box components. They can be components you write your own. They can be components from the community. They can do absolutely anything. So sky is the limit. This is how it actually looks. So you basically have a server, but on top of that server, what you're doing is you are chaining your own middleware components, and you are deciding how web requests are processed in your own custom flexible server. Basically, in terms of the implementation itself, and we're going to talk about it in a minute, In terms of the implementation itself, we choose to do a few things. As I mentioned already, we did choose a worker role because it feels more natural in terms of the things it has to do. Because it has to do continuously some stuff, it's more natural to think about this solution as being implemented as a worker role. The other one is we wanted to be cool kids, right? And cool kids today use what? MVC and Web API. So even if we're doing our own custom web server, we want to do ASP.NET on top of it. And we want to do Web API on top of that. So we don't want to go into the new things and learn things that we're not familiar with. We're good at MVC, we're good at Web API, so we want to use that. We want to keep using that, even if under it, we're sort of shifting the world and shuffling things around. The third one is we decided to use OWIN and Microsoft's Katana project that builds on the OWIN specification. And finally, because we need security, right, we decided to use Windows Active Directory. So let's take a look at the actual solution. And we'll switch. So Roxana is going to show us now some of the details of implementation. Unfortunately, having 1 hour to talk about this is just like scratching the surface from 10,000 meters. So we're going to show you just a few things, the most important ones. But I hope at the end of the day, you will find the topic interesting enough so that you take a look on your own and see what the heck is this Katana project and what the heck is this OWIN specification. And actually, what the heck was Ciprian talking about for an hour? It looked interesting, but it's like,
So I have here the worker role implementation. I will show you the worker role class, which is derived from role entry point and has 3 important methods: run, on stop, on start. Let's focus on the on start method. This line here, var endpoint, it's a role environment, current role instance. It's the part where I retrieve the configuration for my endpoint.
Yeah, so here's one interesting thing. We defined an endpoint for our worker role. Not very smart, not very unusual. The other thing that we did, again, we wanted to be the cool kids on the block. So as you can see, there's a row before that. If you can just a moment switch back to the source code. We're initializing Unity containers. So we said, well, if we're using OWIN and Katana and stuff, let's just play and also integrate Unity into that because we're a big fan of dependency injection containers. So we've also done that. So yeah, you can go back to the configuration now.
I wanted to show you the endpoints in the REST endpoint test service on my worker roles, REST endpoint test worker endpoints. You can see here I have the management endpoint.
So again, that's full HTTPS stack, everything transport level security. There's no compromise in terms of shuffling the things in your web server, but you're still using the types of technologies that you are used to and accustomed to. And I bet the NSA will be very happy because they don't have to crack again HTTPS, right?
Another important line here is the line where I configure the application and the web server.
Can you just go hover over web app, the class itself? No, the web app. Yes. Yeah, that's one. And you could take a look. It's Microsoft.owin.hosting. That's Microsoft's implementation. That single line, webapp.start, creates the web server. It actually hooks into another method that we use to configure the web server, but that's all that we need to do in order to start our web server that starts listening on a secured HTTPS endpoint inside our worker role, inside Microsoft's cloud, inside the Dublin data center. So now you have it.
And some little things about the configuration. In the web app startup class, the configuration method starts by defining the HTTP configuration object. You can see here the dependency injection container is configured using new Unity dependency resolver container.
Yeah, we're actually just hooking Unity into the HTTP stack so that we can intercept constructors for our controllers, constructors in Web API. So that's how we push Unity into all of this.
And the second part of configuration is the Windows Azure Active Directory options, where I specify the tenant name.
Yeah, and this is the cool thing. This is, anyone knows in the room Vittorio Bertocci? He's the security guy from Microsoft. He knows everything about authentication. He's God on earth when it comes to authentication. Vittorio could do a session on that line only, right? There's a lot of things happening there. In essence, and you can't just wonder how simple this is. In the essence, we're hooking Windows Azure Active Directory authentication into our own custom web stack. And all that it takes is to define the options, give the name of the tenant, and then call that little piece of code there, app.use Windows Active Directory bearer authentication .use web API. And that's where we define our middleware chain of processing. And that's where we say, first, go to Azure Active Directory, authenticate the request, and then give it to Web API. Instantiate a controller, let Unity do the work for instantiating the controller, process the request, give back the result, right? Pretty amazing what you can do with these things today. Yeah, one more word here. Okay, yeah, sorry, please show us the, yeah.
Yes,
control.
about the controller. There is one single information here. It's a simple Web API controller. The authorize attribute, which decorates the controller, and this enables security here.
One attribute on our class, and that forces the custom web stack that we build to go authenticate with Windows Azure Active Directory. I think pretty cool, right? So, because we're starting to be a little bit short on time, let me go back to the slides and go with our third topic of the day, which is security, 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 right? And I'm going to talk in more detail about, oh, sorry, yeah, now you see what I'm seeing. It's cool. So what was our problem? As I mentioned already, the problem was, well, we do want to secure this endpoint, but this is an endpoint that lives in the cloud. This is an endpoint that is built on top of a custom web server. So how do we secure it? And luckily, Katana makes this very simple. The way to do it is, first of all, you want to register your service with Windows Active Directory. And that's because Windows Azure Active Directory, or sorry, I should say Microsoft Azure Active Directory. You know, that's the new name. We're supposed not to use any more Windows Azure. It's Microsoft Azure. Whatever. I just like the way Microsoft changes names, right? You know, in their history, there were a few blunders that made the headlines. You all know about Metro, right? It's like, dude, don't you know there's a company there called Metro AG? It's a small company in Germany, right? It only moves a few billions per quarter, so, right? The other one was Windows Workflow Foundation. That was the coolest one. It's like, dude, have you ever heard of Worldwide Wildlife Foundation? And if not, do you know the panda? It's like, come on, right? So now, unfortunately, they're not changing the name from Windows Azure because there's a company called Windows, right? But because they're rebranding. Anyway, so you want to register with Microsoft Azure Active Directory because Active Directory in the cloud needs to know who you are. It won't authenticate just anybody, right? If I'm nobody and I go to the endpoint of Azure Active Directory and I say, hey, dude, I want to authenticate, right? It's going to be no answer, right? Or I will be refused. Because that security breach. So first of all, you have to register. We'll show you in a minute when you do the demo how you register with Azure Active Directory. Second thing you need to do is, we've already seen that in code. While you are bootstrapping your web server, what you need to do is use Windows Azure Active Directory bearer authentication. Now, isn't that a cool name for a function? Right? It's like, there's this language I love very much. I don't speak it, but I like it. It's German, right? Where they have these words. And sometimes they have words that start here and end there. And they mean something, right? So it's interesting. But this one is a cool... I've had a discussion with Vittorio last year about how they could have named this differently. And there were at least a dozen versions of it, and all of them were longer. So it's weird, but it looks to be the shortest way to name this. Now, there's one thing here in the name that is funny, right? We all know Windows, we all know Azure, we all know Active, whatever that means, directory, authentication. But what does bearer mean? Now, this type of authentication, and why I like it, this is actually OAuth authentication. That's another crazy word, OAuth authentication, right? 2.0 actually. So the bearer token is a special kind of token where you do not have to prove that you have a certificate when you get the token. And it's important again, because that enables you to the type of authentication that we do. On the other hand, it also forces you to protect that token like you protect your life. Because if you lose that token, that's equivalent to losing your password. So that's what bearer stands for. And believe it or not, yep, actually everything that you need to do. Now, if you are the curious kind of person, take a look into the implementation of that. You'll get headaches, okay? Because OAuth 2.0 is anything but simple. There's a lot going on under the hood. So even if it looks simple, don't mistake of thinking about it as a simple process. Fire up a fiddler on your machine, take a look at things that are exchanged there. It's pretty big, it's pretty deep. But I think the big thing for us developers is that it's made easy to use. You hold the power, but you don't have to bang your head against the wall trying to understand tokens, token formats, authentication protocols, and so forth, and so forth, and so forth. So I believe that's a big thing there. And that's what I meant with this slide. So I'm going to skip it. This one too, because we've already talked about the bearer authentication. So let's move on now and take a look, more detailed look actually to, I think I did something wrong here. I touched the wrong button. You know, I'm still used to saying I pushed the wrong button, although I'm touching my screen. Isn't that crazy, right? So, yeah, let's take a look to the demo. Last one of today. And we're going to talk here about, I think we need to stop the presentation, something like that. Yeah, it's good.
So we're moving again to the management portal. I wanted to show you how is the Active Directory configured here. Again, in my
so first thing, you need a tenant. And the tenant is the equivalent of an organization. An organization is the highest level of granularity that you can have in Windows Azure Active Directory. That's where things start from. An organization can have from 1 to any number of users. Actually, there's no hard limit on the numbers of users. There have been tests with hundreds of thousands of users, and the Active Directory in the cloud works very well.
So again, here I configured the applications. you can see the client application that forces the configuration file to be reloaded. I will show you in code. In the configure section, there's one important setting here, the client ID. Where, this one I'll be using in my code to refer the application.
So actually, that's how Azure Active Directory recognizes our client application. If you're not registered into Active Directory, you won't be able to even try to authenticate against it.
So in the client application, the first lines are authenticated to Windows Azure Active Directory. The line here, authentication result is acquire token. It uses the client ID I already showed you before.
And here's another place where complexity is severely hidden from us. As you can see, this is a loop. So we simplified things and we said, well, no, we are not pressing escape. We're just going to call that service. And in the loop, we call every time acquire token. But only the first time we do get an authentication pop-up. So basically, this authentication context class that we are using, if you just hover on authentication context class, to see it defined in Microsoft Identity Model Clients Active Directory. So there's an implementation from Microsoft that helps you use Active Directory services in your application. And what it actually does, it does transparent caching of your authentication token. And it does it using an expiration policy that you, by the way, if you are a PowerShell wizard, you can configure in Windows Azure Active Directory and you can take use of that. So even if we call it repeatedly, basically the second time we call it, that function there, acquire token, will just take a look into its in-memory cache, which runs in process with your application. It will see whether the token is already there. It will see whether it's valid. It will validate the entire context of the token, and then it will give it back to you so that you can use it. So again, it looks very, very simple, but under the hood, there's a lot of complexity there. And here's the thing. I don't want you to get the wrong message. I'm not telling here that putting all these pieces together is just a piece of cake. Because if you do not understand it, I strongly advise against it. Because understanding simple things that hide complex things is the sure recipe for disaster and for security holes. So we can use it, it's simple to use, but make sure you have a deep understanding of what's happening behind the scenes. Because otherwise, simple things are not the best things always.
And this line I highlighted here is the line where the token is attached to the HTTP request.
Yeah, as you can see, basically what we do here is a nice way of having, we just pop in an authorized header with the content of the bearer token. And because it's an OAuth 2.0 bearer token, that's why we don't have to give proof further that we also have the secret that enabled us to talk to the server. And that's what simplifies tremendously things, but also puts the pressure on us on protecting the communication. And the way we do it, as I mentioned, we do it with transport level security.
And the last line is the one where we actually call the service.
Yeah, actually, all the fuss was about this, right? Getting that simple thing, HTTP client, get async, and if you can just scroll to see the entire URL there, yeah, it's just a simple endpoint that maps into our custom server and makes things work. So, unfortunately, we're running out of time. We get into the details. Basically, on any of these topics, we could do a whole session. So we can talk only about Azure Active Directory bearer authentication or about different flavors of Katana implementation and so forth. But I hope you get the idea, and I hope it was interesting to see a real working things on all of this. So if I were to draw a quick conclusion or a quick set of conclusions here in a nutshell, what we needed was a small, a flexible, and a secure web stack built from the ground up that can run in an Azure worker role. So we didn't want all the hassle of having IIS, of configuring IIS, of resource consumption by IIS, and all the other things that IIS do. So what we decided was we go with Katana. Katana is the Microsoft project that implements the OWIN specification. And we felt that since we're living in the cloud, the best way to do authentication is by using Azure Active Directory. So what we've tried to show you here today is what it takes to do, or to be more accurate, to implement a new modular web stack. And if you ask me, that's not a Microsoft official position, but if you ask me, I think this is the future of web stacks on .NET. This is the way to go forward because it has so many advantages. And although I was a little bit mean, I said an alternate title would be the death of IIS. Well, I can tell now that I was a bit exaggerating, right? This does not replace IIS. This is a different way of doing things. If you're still happy with having a monolithic middleware pipeline to process web requests, if you're happy with IIS's performance, which is very good, with IIS's stability, which is very good, then there's nothing you need to change. If you want flexibility, if you want modularity, then this is the way to go forward. And we've wrapped all of this. We had a debate internally on whether we should present the on-premises version of this, because all of the risks involved and stuff like that with Active Directory, with authentication, and all the others. And then we, of course, decided, as always, to rely on the gods of demos. So we decided to wrap it up in a cloud scenario. So we still have a couple of minutes left. Thank you very much for attending this session. I hope it was interesting. I hope it was useful. So once again, thank you very much. If there are questions, we're going to take a couple of questions, and the others will take offline. Thank you very much. Okay, let's take a couple of questions if there are. Oh, yeah, please.
You kept comparing OWIN with IIS, but how does it compare to a self-hosted PCF website?
Well, that's a good question. First of all, I was comparing Katana with IIS, just to make things straight. OWIN is just a specification, okay? Katana implements it. Now, when you talk about a self-hosting WCF service, as you all know, that basically runs on top of usually service host or something equivalent, and internally, that runs on top of http.sys, right? So, in-process type of host that you can build there. And from this point of view, you can say it's similar. The big problem with that is it's not modular and it's not pluggable, right? The only degrees of freedom that you have is the ones that are permitted by WCF configuration. Apart from that, you cannot, or, well, let's not say big words. It's difficult to plug in extra things into the pipeline. If you ever attempted to do a processor in the WCF pipeline, then you know what I mean, right? So it's difficult. It breaks my heart to say that OpenXML and WCF, I say, passed the top of their popularity, right? We're sort of living in a different world right now. So although it's still a powerful technology, it's still a powerful stack, and it's good for many things, we actually use it today for many projects, it's still monolithic. So I would say the big difference is it's still monolithic. It doesn't enable you the kind of modularity and the kind of flexibility that an OWIN implementation does. I hope that answered the question. Yeah. By all means, no. No. I think a few years ago, somebody predicted the death of Windows XP. They were wrong. Okay. So predicting the death of any technology, especially one that is backed by Microsoft. You know, Microsoft implements two types of technologies. The one they back and the others they don't back, right? And there are some technologies they say they will back, but they don't do it, right? Well, by all means, no. No, I think WCF is here to stay. It has lots of important applications, and there are things that you can do with WCF which are impossible to do the other way. Okay? It looks like there are no other questions, so we were either very clear or we were very cumbersome, right? So once again, thank you very much and have a nice conference. Thank you.